Okay, chapter 24.4, the sun, earth, moon system. We've talked about the sun individually, the moon individually, and the earth individually. Now we're just going to talk about how they interact. Most of this stuff, I'm going to be honest, you guys probably already know. There may be a little bit in there that you go, never knew that. Okay. So here we go. By the time we're done, you should be able to describe how Earth's movements affect seasons and cause day and night. You should be able to explain solar and lunar eclipses, describe the phases of the moon and explain why they occur, and explain how movements of the Earth and moon affect Earth's tides. So hopefully by now you already know that the motions of sun, earth, and moon all together affect our day and night. They affect our seasons, and they affect tides on Earth. Well, they also affect the phases of the moon. And if you don't know what phases of the moon are, then hang on because we'll get those in just a minute. Are you good? You should also by now know that it takes 24 hours for Earth to make one rotation on its axis. So if we start right here, it takes us 24 hours to go one time around on our axis. You should also maybe not know that our planet moves clockwise around the poles. So it looks like the sun, the moon, and the planets are moving from east to west. They aren't. We are. Okay? In case you didn't know that. Hopefully by now. You guys all know that the sun comes up in the east and it sets in the west, right? You know, the moon does the same thing. That's what it means when it says it looks like it's moving that way. Earth's seasons are not caused, remember, by how far away Earth is from the sun. It's caused by the tilt of our axis. A lot of you got this wrong on the study guide from the last section. During summer solstice and during the summer in the northern hemisphere, we're here on this part of the picture, we are tilted toward the sun. That means we get more direct sunlight. As a matter of fact, the Tropic of Cancer, which is, there's the equator is directly in the middle. The Tropic of Cancer is at 30 degrees north. The Tropic of Cancer gets direct sunlight at that point. June 21st to 22nd, depending on which day it is, it's different, is the summer solstice. That's when we have the longest amount of daylight and the shortest amount of darkness. Okay? The northern hemisphere, as I said, is tilted toward the sun, so we get more direct sunlight, which means we get more energy, which means this is our summertime. In the summertime when all the fields... Never mind. Are we good? So on the opposite side of that, in the winter, we are tilted away from the sun. The Tropic of Capricorn, so Tropic of Cancer is at 30 degrees north, equator is at 0 degrees, Tropic of Capricorn is at 30 degrees south. The Tropic of Capricorn is getting all of the direct sunlight. We are tilted away from the sun, so we get less direct sunlight. So this is our winter. December 21st or 22nd is the winter solstice. This is the day that has the shortest amount of daylight and the longest amount of darkness. Okay, Mrs. Skipper, so what's those two places in between? September 21st and 22nd and March 20th or 21st are called the autumnal. That would be the fall equinox. That's when we're going from summer to winter, so that's going to be here. And the vernal, which means spring, equinox, and that would be here. During the equinoxes, we have equal amounts of day and night. We have 2 of those every year. There are exactly the same amount of daylight hours as there are nighttime hours. I like this equinox because, or no, this equinox because that means the days are going to start getting longer. I don't like this one because that means the days are going to start getting shorter. I don't like them. Okay? Eclipses. If you don't know what a shadow is, then you have to go know what a shadow is before you can know what an eclipse is. And a shadow is an area where an object obstructs a light source so that the darkness takes on the form of the object. Remember, we talked about playing shadow games with your hands, and you'd make different shapes with your hands with a light source here. And then you'd make a shape and it'd show up on the wall. Okay, it's the same thing. A solar eclipse is when the new moon passes between the sun and earth. Okay, sun, earth, moon. The moon's shadow, it does not make a shadow on the sun. Guys, seriously, somebody's going to get this wrong on the study guide. It does not make a shadow on the sun. If the sun is here, that's the light source. Here's the moon, and here is Earth. It makes a shadow. The moon makes a shadow on Earth, not the sun. But it does block our view of the sun. It doesn't last very long, and they don't happen very often because the moon is so little that it doesn't cover the sun for very long. And it has to be just right to even cover the sun. By the way, this is a picture of a solar eclipse in the process. So you get just a little bit and then a little bit more until this is actually a full solar eclipse, and then it just moves right back off. A total solar eclipse is when the whole sun is covered. It'll look like this. A partial eclipse, I know, right? Is when only a part of the sun is covered. We are going to have more partial eclipses than we will have total eclipses. Total eclipses are really weird to experience. I don't know if we've had, I can't remember, but it'll be like this beautiful, bright, sunny day. And then all of a sudden it'll start to get dark. The birds will start, quieting down. Everything kind of starts to get quieter, starts to get colder as the moon moves across the sun until it's completely covered. And then it's like, it's the quiet. It's like at nighttime. And then it'll move across the sun again and everything will come right back up the way it was before. And it's a matter of minutes, not hours. The other side of that is a lunar eclipse. These happen when a full moon moves through Earth's shadow. So in this case, it would be the sun, Earth, and the moon, because it's going to be a full moon. The Earth's shadow actually has two parts. It's got a big part and then a little tiny part that's kind of a cone shaped. Okay, the first one is called the penumbra. It's the outer part. Only part of the light is blocked in the penumbra. This is going to be the big part here. The penumbra is the big part. The little part is the umbra. It's the inner part right here. And this is where all of the light from the sun is blocked. Are we good? Total lunar eclipse is when the moon actually moves through this penumbra. I'm sorry, this umbra. Blah, 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 blah. The moon's going to move through the umbra and you won't be able to see it. It just kind of goes dark. A partial eclipse is when only part of the moon moves through the umbra. Kind of makes sense, guys. Total means it's completely there. Partial means it's only partly there. Nobody should be really surprised by that. Lunar eclipses, solar eclipses, remember, last only minutes. Lunar eclipses last for hours because our shadow is a whole lot bigger than the moon's. You good? Okay. Okay, now the phases of the moon. There are a lot of them, as you can see, looking at this, there's a lot of phases. Most of them are repeated. So we're going to start the moon. Oh, yeah, I forgot. Remember, the moon only reflects sunlight. So as it moves around our planet, we see a little bit of it or none of it or all of it. All right. And remember, we really only ever see how much of the moon? Half. Even when it's a full moon like this, we are only seeing half of it, right? Because we can't see the back. We never see the back. All right. So we call these parts that we see, we call them phases. And they start with a new moon and end with a new moon. And it takes them about 29 and a half days to go through all of the phases and back. So basically, you get a like new moon, quarter moon, full moon, quarter moon, new moon every week. The gibbous and the crescents fall in between those. All right. So, what happens with a new moon is the moon moves between the earth and the sun, so no light is reflected off the moon. It's kind of like a mini eclipse, only it doesn't eclipse the sun at all. It just, you can't see the moon anymore. You may be able to see like the outline of the moon a little bit, but it's mostly going to be dark. If you're going to run away from home, this is not the day to do it. You'll get lost. You can't see anything. Just saying. Don't run away from home. Okay? The waxing crescent, that's this one. This is when the moon is less than half illuminated on the right-hand side. My family never called that a crescent moon. My family always called it a thumbnail moon because it kind of looks like somebody's just taken their thumbnail and stuck it up there, right? But the official name is a waxing crescent because it's getting bigger, so it's waxing. The first quarter moon is when you see a quarter of the moon. I know, Mrs. Skipper, that's half the moon. No, it's not, because remember, we don't ever see the back. This is a quarter moon. This happens about a week after the new moon, and you get the whole right half of the moon illuminated. Then, in between the quarter and the full, you have what's called the waxing gibbous. It's more than half, but it's not completely full, and it's illuminated on the right-hand side. Remember, if it's on the right, it's waxing. Okay? Wax on, wax off, wax on. Sorry. Movie references.
I know about 750,000 releases, including Evolve by Imagine Dragons, Traveler by Chris Stapleton, Perception by NF, and Life Changes by Thomas Rhett.
Alexa, off. Wasn't asking you anything. Weird. Are we good?
No. Where's that slide at? Which slide is that?
I don't know for you. For me, it's probably like 50 something. I don't know. 14?
Oh.
We'll come back. Let's get them done, and then we'll come back and give you that one, okay?
I was just lost.
The full moon is like halfway through the moon cycle. The full moon occurs when the earth is between the sun and the moon. But the moon doesn't actually fall. Put that phone away or it's going to be mine. The moon doesn't fall into the umbra or penumbra. So it's actually completely illuminated. So it's really a half moon. But we call it a full moon because you can see all of what we can see. This happens about 2 weeks after the new moon. Or 1 week after the first crescent. Oh, look, I put that in there. This happens approximately 2 weeks after the new moon. Okay? Then it starts to get, the amount of the moon that we see starts to get smaller again. So we have the gibbous are the 3/4 moons, kind of. All right? You can see about 3/4 of what's visible, what should be visible. So the waning, as it starts to get smaller, we call it waning. As it's bigger, it's waxing. Smaller, it's waning. Is the left side of the moon is almost all illuminated. Somewhere between full and half or quarter. The last quarter is the left half of the moon shines. You can see the left half. So here's a question. Are you ready? How much time is there between a first quarter and a last quarter? Two weeks, okay? Because I told you each quarter takes about 2 weeks. I'm sorry, each quarter takes about a week. So new moon to first quarter is 1 week. First quarter to full is 1 week. Full to last quarter is 1 week. So if I went from first quarter to last quarter, well, look, first quarter, full, last quarter. Yes? I'm telling you this because it might show up on your study guide tomorrow. Just putting that out there. Okay, waning crescent means that less than half of the left side of the moon is illuminated. Yes, we called that a thumbnail moon too. That is not the right, and by the way, if you put thumbnail moon, it will be counted wrong. It's a waning crescent. And then we are back to a new moon. Questions? Okay. Tides. Everybody knows what a tide is, right? Does anybody not know what a tide is? In case you don't, there it is. They are the rising and falling of Earth's surface waters as a result of the gravitational pull of the sun and the moon. So if you live near a coast, high tide is when the water comes in. Low tide is when the water is far away. Okay? As the moon revolves around our planet, the moon's gravity is going to pull on Earth's waters and make it bulge in whatever direction the moon is facing us. All right. The sun has some gravity too and works on it too, but the moon's gravity affects our tides more than any other thing does. This spot, so if the moon is here, this spot on our planet and the spot directly opposite it are both going to experience high tides. So if the moon's here, this part is going to experience a high tide, and this part is going to experience a high tide. If the moon's here, then the North Pole is going to experience a high tide, and the South Pole is going to experience a high tide. As the moon moves around, our tides do that too. And it's always the part that's facing the moon and the part directly opposite it. The parts in between those two places are going to have low tides. So you could say the parts perpendicular to it are going to have low tides. Every day there are 2 high tides and 2 low tides, which makes sense because the moon is going to be here and then it's going to be here. So this place is going to experience a high tide when the moon is here, and this place is going to experience a high tide when the moon is directly opposite it. There are 2 other kind of tides we have to talk about because the sun's gravity gets involved sometimes too. It doesn't have as much effect on the moon. Now, some of you are going, wait a minute, Mrs. Skipper, the sun's way bigger than the moon. The sun's gravity should affect it more than the moon's gravity does. Well, but the sun is way far away too, and the moon is like right there. Right? That's why the moon affects it more, because the moon is closer. Okay? When the moon and the sun line up during new moons and full moons, we get really high tides and really low tides. So high tides are going to be higher, low tides are going to be lower. We call this a spring tide. So spring tides happen here when the new moon is here and when we have a full moon here. Really big tides for the high tides and really low tides for the low tides. Last tide we have to talk about. Guys, we're almost done. Can you believe it? I told you there were going to be short notes today. So when the moon and the sun are perpendicular to each other, that means they are kind of at right angles to each other, right? Mrs. Skipper, are you using math terms and science again? I know. So when we have a first quarter and a third quarter moons, the moon's gravity is kind of canceled out by the sun's gravity. So the tides, there's not going to be very much difference between a high tide and a low tide. The tides are all going to look about the same. The water levels. We call this a neap tide. I know it's a weird word. Neap, neap. Call this a neap tide. Okay, that's it for the notes. Do you guys have any questions about what we went over today? Was there lots and lots of new information or just a little bit of new information? A little bit? Okay, good. Because that's what I thought it would be. Anybody, let me stop the